Welcome to Israel Engineering Structural Design Team. In the previous 6 consecutive tutorial parts of 8-story apartment building, we have seen that 3 main basic parts of structural design. The first one is that how to model this 8-story apartment building, especially how to draw shear wall for lift and basement, how to draw staircase, column, beam, and slab. And the second one is how to calculate, assign, and combine vertical and horizontal loads. And the third one is that how to assign diaphragm and mesh the slab. Today, I will show you how to analyze and design this 8-story apartment building. When we say analyze this apartment building, we have gates, the internal reaction, that is a shear force, moment, and axial load at the base. And the second part that we have seen in today's tutorial is that how to design this 8-story apartment building to get or to provide sufficient section and reinforcement. After completing watching this video up to the end, you have mastered ETABS software and structural designs of complicated projects. Don't forget subscribe and share this channel to get more updated videos daily, all about civil engineering softwares, structural design, construction techniques, and soil stability mechanisms for mega projects. Let's dive into today's tutorial. After modeling your building, it's better to assign all vertical and horizontal loads. Then after assign all vertical and horizontal loads to your project on slab and beam, it's better to proceed to mesh your slab and your vertical walls, like your shear wall. And after that, it's better to go to analysis. After that, you have to check your model for if there is any repeated or any lapped section that may be your slab or your column. Then it's better to check your model. Okay, click check your model. Then after this, you have to select all these data that is due to check your model. Instead, it's better to select all here. After that, make it okay. The software itself is going to check all your models. So the warning message is appear here. Our model have been checked. No warning message were generated. So our model is good. So it's better to proceed to the next analysis part to get our internal reaction like shear force, your movement, and that of a base reaction or axial load at the base for foundation design. So make it cancel. Go back to analysis. After that, it's better to click on run analysis. Okay, the software itself is going to analyze your project model like this. It takes some time, so it's better to. Okay, our analysis is finished like this. So make it a start animation. Okay, our building is look like this due to the force that is applied on it. So the slab go up and down due to the force that the load that we have assigned on it. So due to protect or to safeguard this force, it's better to provide a reinforcement. I will show this tutorial or this assigning of or providing of reinforcements and section in the design part. So after this, you can stop your animation and go back to show all your necessary analysis results. I will show all the necessary analysis results by clicking on the display menu. After this, it's go back to force or stress diagram. By force and stress diagram, it's better to select frame peer expander or link force. After this, to show your maximum moment due to, for example, for factored load compression, it's better to select a shear 2-2, that is a maximum shear, and a shear 3-3, that is a minor shear. And for in case of your movement 3-3 is a maximum movement, and that of a movement 2-2 is a minor movement. So first, it's better to show you our maximum shear. So make it fill in, click on fill in diagram to show in diagram, and it's better to select also show a value at each contour. So make it okay. Go back to your plan. I will show all this data from first floor slab. So our shear is appear like this. After that, the shear is maximum. As you know, the shear is maximum around the support, and it is minimum at the mid part. So and it also become maximum at the support condition. So our shear is calculated and appeared like this by the software itself. So I will show also your movement, your maximum movement around the span and at the mid parts of your slab. So go back to display, force or stress diagram. Click on here. So select your maximum movement, that is a movement 3-3. Apply. Okay. All the movement is appeared like this. All the movement for your beam is appeared like this. So you can provide a reinforcement using this maximum movement. The movement at your support, and the movement at the mid span and that of around the support is look like this. So you can select this beam and provide all your reinforcement rather than you have to go to a detail. Simply you can calculate the reinforcement detail on using a hand calculation, or the software itself gives all the reinforcement that provided for this maximum movement at both the span and the mid of your beam. I will show also the maximum movement, that is the field movement and support movement on your slab by selecting one panel. So to do this, it's better to go to display. After that, go to force or stress diagram. Go to shell stress or force. Shell means a slab. So to get a slab maximum field and span movement, it's better to use your factored load combination. So make it okay. All the calculated movement looks like this. So the software itself gives a maximum movement of 35.83 kilonewton per meter square, and a minimum reinforcements of 150.89 kilonewton per meter square at this coordinate, that is 90.8.3, 3.3, that is XYZ respectively. So you can check also any point by selecting, for example, this panel, that is the panel between 3, 4 to BC, that means this panel. So the maximum movement is the maximum movement for the field, or for the field is 11.33, and that of around the support is like this. You can check any movement at each point by simply clicking on each place. So after you have gates your internal reaction, that is the shear force, your movement, and axial force like this. I will show also your axial force at the base. To know this, it's better to use unfactored load or a service load. So make it okay. To get your base reaction or reaction force or axial force at the base level, make it select your plan at the base and make it okay. So all the reaction force, including the movement in x and y direction, is appeared like this. So you can use this data for your foundation design by factoring the loads. And the next part for today's tutorial is that how to design your project. After analysis your project, you have to get your internal reactions. After that, I will show you how to design your project, that is 8-story apartment project. And after you design your project, you have to provide your sufficient reinforcement and that of sufficient section. So go to design, go to design menu. So our project is a concrete frame design or a concrete structure. So go to concrete frame design. After that, it's better to select all your load combination. So select design combination. After this, you have to transfer your list of combination to design combo by selecting all this data. It's better to transfer to your design combinations. After that, by pressing your control key on your keyboard, you can select all these load combinations that we have combined in the last or in the previous tutorial. That is all your 42 load combination. You can select by pressing your control key on your keyboard, and by selecting all, you can transfer to your list of combination, your list of load combination to that of a design combination. After that, it's better to make okay and go back to design, concrete frame design. After that, go to start design and check. After this, the project or the software itself is going to design all your frames. At this time, the project is design your horizontal frames, and go back to it's proceed to your vertical frame, that is your column and shear wall itself. I will show all the final results after the project finishes the design by itself using the data that I have filled on it. So all the designs of your frame is completed like this. I will show this by going to first floor plan and select one elevation. For example, it's better to go back to your grade beam at your foundation at your basement level. So here in the basement, some columns are go to a red color, that is the failed one. So it's better to add some section. I will show how to add some section and how to solve this problem. All the reinforcement detail and the sections of your beam is good on the basement floor level, but some column are failed like this. I will show the failure type and how to correct this failure. Okay, before this, it's better to check all your beams. All your beam is better, and all the reinforcement detail is coming like this. Change this value into this reinforcement area value into reinforcement. It's better to divide this area into that of area of reinforcement simply. So after that, it's better to proceed to correct all your failed column. To do this, it's better to go to your elevation. So all your column appear like this. So So column B4, that is the failed one, and that of 4C on axis 4C are failed. So it's better to go to correct this column. Before that, for example, it's better to show the failure type. So go to display, go to display, go to design, concrete frame design, design information. So after that, select identify all failures. After this, you can get the failure types. For example, some beams are failed due to due to torsion force. So it's better to provide a torsional reinforcement or add section. And our column is failed due to PMM, that is the major movement failure. So the major movement failure is actually cancelled by adding some section or reinforcements. So to do this, it's better to select your column. Select your column. For example, this column is column 35 by 60. So it's better to add some sections for this column. The column, for example, okay, the last column that is failed, that is column 2 comma D. Okay, column 2 comma D. So it's better to go to unlock your model. After that, go to define section property, frame section. After that, you have to select your column, edit your property. After this, it's better to add some section, that is 40 and 60 to 70. After this, it's better to select 40 by 70, make it okay. So you have to analyze it again and go back to design to check your column. Okay, the software is going to analyze your project. After that, go to design, start and check your design. That we have to change your section for column 2 comma D. Don't forget the coordinate, that is column 2 comma D. After this, I will check it again. After changing the section, after changing the cross section, it's better to analyze and design, and further that it's better to check 2 comma D. Okay, this column. Okay, this column is not corrected, so it's better to add the section again. So assign, go back to design section property. So after this, column 50 by 70. So column 50 by 70. To be economical, it's better to check any section by adding any number here. So make it okay. After this, it's better to go to analyze and design it again. Okay. Start design your project. After that, I will check it again. Your design looks like this. Its design is simple using this software by simply adding your cross section and calculate the software calculates the reinforcement detail area, and you can divide it to your divided it to your area of reinforcement that you have to use. So go back to check your column, that is column 2 comma D. Okay, column 2 comma D is safe now. It's safe to now. So after this, it's better to divide this area of steel to your selected diameter of reinforcement. So designs of your project looks like this. Thank you for watching this video. In the next tutorial, I will show you all about detailing. So don't forget subscribe, like, and share this YouTube channel to get more updated videos on civil engineering, software, structural design, construction technique, and that is of how to stable your soil for mega project structures. So all about soil stability. That means we will see in the next tutorial. Goodbye.